Welcome to our new unit of geometry. Woohoo! Very exciting. Ooh. Okay, in 7th grade you do geometry. You do a ton of geometry actually, like so much. We only do a little bit of geometry in 8th grade. It's really mostly algebra-based geometry, and students tend to like it. It is a breath of fresh air after doing functions all year, so get excited. Of course, starting the unit, we're going to look at some vocabulary, so make sure you have your notebook out. The diagonal is a very familiar word for you. This shouldn't be new for you. So for example, here I have a rectangle, like a piece of notebook paper, and from one corner to the opposite corner, when I draw that line in, that is the diagonal for the shape. Okay, all rectangles have two diagonals, one from corner to corner there, and then you could also say there's a diagonal from corner to corner there. In fact, the diagonals of rectangles are congruent, and that's something that we're going to look at this unit. Okay, so right here, we could calculate the length of this diagonal because you see we had this right angle that's formed in every corner. Of course, it's a rectangle, and so we end up with two right triangles, and we can do Pythagorean theorem in order to calculate that diagonal's length. So here we would just do a squared plus b squared equals c squared, and so we would let 11 be a and 8.5 be b, and then solve for c. So 11 squared plus 8.5 squared equals c squared, and we would try to figure that out. But we don't need to do that now. We'll be doing that plenty today. So this is a little bit new. This is a diagonal through a 3D shape, through a rectangular prism, and it is called the space diagonal. So go ahead and get that in your notebook. The space diagonal has to go from one vertex to the opposite vertex. Notice that it is going through the space of the prism, and it is only touching one vertex here and one vertex here. It's not touching any other vertices or edges of the prism. It is traveling through the space of the prism, right? Versus if I did from this vertex here to this vertex here, this diagonal travels along the face of the prism. That's just a diagonal of a rectangle. Or same thing if I did from this vertex here to this vertex here. Again, that diagonal is traveling along the face of the prism. Even if I did, if I was trying to do one from here to down here, that's traveling along the bottom face of the prism. So the only way to travel through the space of the prism, hence the name space diagonal, is to go from one vertex to the opposite vertex where there's no faces or edges or vertices, just the two on each side, which is why it's called the space diagonal. If this is hard for you to visualize, you can go to the next slide and there's a little 3D shape for you to play with. Just make sure you come back and pick up the video here. If you feel like you have a strong understanding of what it is within the shape, just continue to watch and then you can look at it after. Our goal is to calculate the length of the space diagonal if we have the dimensions of a shape. So here you can see the right triangle that's been drawn in the prism. And notice that the side length C, the hypotenuse for that triangle, is our space diagonal. That is the space diagonal through the prism that we just looked at. Also notice though, in order to calculate that, we need the height of the prism. Okay, here we could say B is the height, right? The height of the prism, as well as the diagonal of one of the faces of the prism. So notice that here's this base down here, right? You see the base. And that A length is the diagonal of that base. It is the diagonal of that base. So we have to use the length and the width of the prism, right? The length and the width, whatever they are, of the prism to help us figure out what that diagonal of that base is, and then use that to calculate the space diagonal. So this is a lot, in words to take in, right? It's a lot in words. So let's try one and see how we do. So again, we have to use Pythagorean theorem 2 times. Pythagorean theorem 2 times. Oh man, doing some math in math class. So I encourage you to pause the video and see for the figure below, can you first solve for x and then solve for y? So first solve for x and then 2 solve for y. Pause the video and try that now. Okay, so hopefully you were able to do this, and if not, I'm going to start going over it. So there's a triangle right here, right? Again, here's that base, right? There's a whole rectangle there. We looked at that. And then that rectangle has this lovely diagonal right here. And so in order to calculate that length, we're going to do Pythagorean theorem. And so it's like we have a rectangle that looks like this. And we have the 3 and we have the 4. And then we have x. Well, if you recall from last year, your Pythagorean triples, 3, 4, 5 is the Pythagorean triple there. It is a 3, 4, 5 right triangle, so we know x has to be 5. Or you can do 3 squared plus 4 squared and solve that. You'll get the square root of 25, which is 5. Okay, so now we know, I'm going to do a little changing. Now we know that x is 5. So this length is now 5. So now we're looking at a new right triangle. We're looking at this right triangle here. It uses the space diagonal of the prism. And so we have side length 5, 12, and y, which is a space diagonal. Again, if you look at Pythagorean triples and know your Pythagorean triples, that's a 5, 12, 13. So in other words, if I did a squared plus b squared equals c squared, I get 5 squared plus 12 squared equals c squared. And then I add to the square root of both sides, and I get c is 13. Or I could have replaced c with y. So y is 13, right? Y is 13. Okay, so the length of y here is 13. But again, notice how we had to do Pythagorean theorem twice in order to calculate that value. Ooh, that's a lot of work, right? I know. So there has to be a quicker way. There has to be a quicker way. Let's say we have a prism with length L, width W, height H, and diagonal G. Go ahead and fill this in your notes. Again, I encourage you to pause the video and see if you can mimic what we just did with variables only, and if you can derive what the formula for the diagonal is here. I'll give you a hint. It's very similar to Pythagorean theorem. It's just instead of 2 dimensions, we have 3. So it alters the theorem because we're having to calculate it twice. So pause the video and try that. Okay, so if you paused it, that's fantastic. I'm going to go ahead and start going through it. So here, I'm going to draw in this diagonal. We have this. I'm going to draw this diagonal right here. Right, that's the diagonal for the base of our prism. So right, I have this rectangle here. And then I drew the diagonal through that rectangle. Right? So that rectangle's diagonal, we can let that be C. I'm going to just call it C for now because we're going to do Pythagorean theorem, so I might as well. And so let's say I'm going to just do Pythagorean theorem and substitute. Like normal, we're just doing it with variables instead of with numbers. So A squared plus B squared equals C squared. So our right angles here. So let's say A is L, so L squared plus B is W, so W squared equals, and we called it C. We're going to keep it C squared. Well, if I want to solve for C, if I want to solve for C, I would just take the square root of both sides. Okay, so I'll just go ahead and do that. I'm going to just take the square root here, so I get C is the square root of L squared plus W squared. Now, I can't take the square root of the length or the width because they're not being multiplied, they're being added, right? It's like it's almost like a perfect trinomial. I cannot take any square roots here because of the addition. So this is our final answer, simplifying, for what C is. So now we're going to take a look, and now I'm going to focus on finding the space diagonal here. Focus on finding the space diagonal here. Okay, and so if I do that, there's my right angle. Now, C is one of my legs, right? So if I have A squared plus B squared equals C squared, just adjust my page width here. Right now, C is one of my legs. Okay, and so I'm going to let my A be C, but we know C is really big. So I'm going to substitute that in. So we got the square root of L squared plus W squared, all squared, plus this is my height squared, equals my diagonal. Well, the square root of this squared, there's that inverse operation again, goes away. So now I have L squared plus W squared plus 8 squared equals D squared. Look at the similarity between how we find the diagonal of a rectangle and how we find the space diagonal of a prism. Right? What's the difference here? Well, with a triangle, when we're looking for a 2D shape, we have 2 dimensions, the 2 legs that we're looking at. When we're looking for a prism shape, we have 2 dimensions, the length, the width, and the height that give us those dimensions. My goodness, we can't even read this page now. So go ahead and copy this page in your notebook. Notice that we can solve for D by taking the square root of both sides.